In this video, I wanted to talk about basic trig functions, trigonometry using SOHCAHTOA. So real quick, you may have been given this great little cheater, SOHCAHTOA. It's a little messy. We are the messy math tutor. So SOHCAHTOA, this is a way to remember sine, cosine, and tangent. So what each of these mean are opposite. O is for opposite, H is for hypotenuse, and A is adjacent. So SOHCAHTOA only works for right triangles. So I'll say that again, SOHCAHTOA only works for right triangles. So if we were given something, and these are, usually we use large capital letters for the angle, and then we would use little letters for the sides. So it's always good when we're talking about trig to kind of distinguish yourselves. It seems kind of simple, but distinguish yourself between angle and side. So am I looking for an angle or am I looking for a side? So back to SOHCAHTOA, S-O-H, so means that sine is equal to opposite over hypotenuse. So if I were standing at A, I position myself here, and I could write sine of big A equals opposite, that would be opposite of that angle. So in our case, that would be little a over hypotenuse. Hypotenuse is always the big diagonal and the side across from the 90 degree. So in our case, the way we have that labeled, that would be B. So this could be a lot of different scenarios, right? If we were given actual numbers here, we could put those numbers there as well. So that would be sine. So now let's go to cosine here for C. So ca, C-A-H. So cosine is adjacent over hypotenuse. So again, if I'm standing here at A, the cosine of A would be adjacent, and adjacent to A, the angle, means it touches it, and it's not the hypotenuse, so it has to be C. So that side that is adjacent to our angle A would be C. C over B. That would be cosine of A is adjacent over hypotenuse. And then the last one we'll do is tangent. So T stands for tangent. Tangent is OA. We already talked about the O and the A. So that is opposite over adjacent. Opposite over adjacent. So in our little scenario here, if we did the tangent of A, I picture myself sitting here at the angle. The opposite, I go straight across from that angle to the side that is straight across. Opposite of A in our case is little a, and the adjacent is C. So the tangent of big A would be little a over C. So let's do some examples. So we'll keep SOHCAHTOA up just so that we can see how this works out. So I'll do here a very common, we call these triples. If we were given the sides, 3, 4, 5, these always go together. And why? Because of Pythagorean, right? 3 squared plus 4 squared is 5 squared. So that's what we call triples, is these sides that are always together, 3, 4, 5. And it's because of this. 3 squared is 9 plus 4 squared is 16. 9 plus 16 is what? 25, and 5 squared is 25. So 3, 4, 5 always goes together. So that would be a triple. So now let's label our angles here. This time we'll call this A, B, and C. So in a 3, 4, 5, that's not a special triangle. Those are some decimal angles there. So let's call this, if we wanted to know the sine, if we said the sine of A, so now our A is down here. If we're sitting at A, the opposite, so sine is opposite over hypotenuse. So sine is opposite over hypotenuse. So for us, sine of A in this scenario would be opposite of our angle, which in this case is 3, and our hypotenuse is the big diagonal, so in our case would be 5. So in that case, the sine of A would be 3/5. And we would always want to reduce if we needed to our reduced fraction. So that one's already simplified. So now let's do the cosine. So the cosine, so ca, AH, so the cosine of big A would be adjacent over hypotenuse. So for us, cosine of big A, in this case, the adjacent to big A, if I'm sitting here at A, here's my angle, adjacent to A is 4. 4 over the hypotenuse, which is 5, 4/5. So now let's go back to tangent. So if we were to do tangent of A, TOA, tangent is opposite over adjacent. So for us, tangent of A, opposite is 3 and adjacent is 4, opposite over adjacent. So in our case, tangent of A would be 3/4. So we could do any of these. If we needed to know an angle or a side, we would be given those. So if we needed to know an angle and we were only given sides, we would need to do the inverse. So if we were given just this exact scenario and they said find A, we could have used any of those trig functions. It's a right triangle, so I can use SOHCAHTOA. I have all 3 sides, so I just need to know those angles. So in that case, in our calculator, there's an inverse button that looks like this. It'll be for sine, cosine, and tangent. So I could use any one of those trig functions. So in my calculator, I put the inverse of the answer equals the angle. So that's what I was saying at the beginning. If you keep yourself square on what are sides and what are angles, seems simple enough and pretty obvious, but figure out what they're asking for. So my variable here is an angle. So that means to solve it, I would do the inverse of the answer. This is my answer that includes sides. So the inverse of these sides would give me my angle. So in that case, if we plug that into our calculator, let's see, the inverse of 3/4, and you could just put the fraction in your calculator and make sure you're in degrees versus radians. So in this case, this is a decimal. This is 36.87 degrees. So depending what your teacher has asked, you could leave it as 2 decimal places as degrees. If they wanted to know it in radians, you could certainly convert. So that is basic trig functions using SOHCAHTOA.